An invisible river of ocean water is moving upstream, against the current of the Mississippi. Not a flood, not a chemical spill, a deliberate, silent invasion from the Gulf of Mexico, creeping along the bottom of America's most vital waterway. This is the saltwater wedge, a tongue of dense saline water pushing its way inland, driven by a simple, terrifying reality. The Mississippi River is losing its strength. It is failing to push back. For months, communities along the lower river have been watching, waiting. The crisis is not marked by rising water, but by its opposite, by cracked earth on the riverbanks, by barges running aground in mud that should be 10 feet below the surface, by the quiet, unnerving taste of salt in a glass of water drawn miles from the sea. People are now witnessing an event that for decades was a hypothetical, a problem for engineers and hydrologists, a problem for the future. But the future is here. At the water treatment plants in and around New Orleans, technicians monitor chloride levels hour by hour, watching a number that cannot be allowed to pass 250 milligrams per liter. That is the EPA's secondary standard, the line between fresh water and brackish water, the line between safe and corrosive. What is happening in the dark, at the bottom of the river, is threatening to cross that line and poison the water supply for nearly 1 million people. It's a strange thing to imagine an entire ocean pushing a river backward. Curious what you think about this, actually. But here is the detail that tells the real story. To fight this invisible invasion, the U.S. Army Corps of Engineers does not build a wall on the surface. They build a dam underwater. It is called a sill, a massive ridge of earth and rock, 1,500 feet across, and piled up to 35 feet high from the riverbed, constructed in the path of the saltwater wedge. They have been doing this near Southwest Pass, the main artery for shipping at the river's mouth. The sill acts as a submerged barrier, forcing the denser, heavier saltwater up into the lighter, faster freshwater current so it can be flushed back out into the Gulf. It is a desperate, ingenious, and temporary solution. A multi-million-dollar earthen bandage on a continental scale wound. And in the autumn of 2022, and again in 2023, they had to build it. A once-in-a-decade emergency measure was becoming an annual affair. To understand the mechanics, you have to understand the balance of power. The Mississippi River, draining 40% of the continental United States, normally pushes into the Gulf of Mexico with such titanic force that it keeps the ocean at bay. The magic number measured in cubic feet per second dictates this battle. When the flow at New Orleans stays above 150,000 cubic feet per second, the river wins, the freshwater pressure is too great, the salt is driven back. But when persistent, recurring drought starves the river's upper tributaries, the Ohio, the Missouri, the Arkansas, the flow slackens, it drops below the threshold, and the Gulf, ever present, begins its patient advance. The saltwater, being approximately 2.5% denser, sinks and flows inland along the dredged-out shipping channel like a current in its own right, sometimes for dozens of miles. This is the part that is not just a local problem. It is a symptom of a system under immense strain. The entire 2,340-mile length of the river is feeling it. Zoom out, and the scale of the system is almost impossible to comprehend. 31 states and 2 Canadian provinces funnel their water into this one great channel. It is the nation's breadbasket, its industrial highway, its historical core. We have spent more than a century trying to tame it. The U.S. Army Corps of Engineers, established in 1802, has built levees, revetments, and spillways to protect against floods. They have straightened its course to speed navigation. And critically, they have dredged it, digging a reliable navigation channel 9 feet deep on the upper Mississippi, and a staggering 45 feet deep from Baton Rouge to the Gulf. We engineered a highway for commerce, and in doing so, we may have inadvertently created a perfect pathway for disaster. That deep channel, essential for giant ocean-going vessels, is the same channel that now provides an unobstructed route for salt water to penetrate deep into the heart of Louisiana. History shows the river has always been a place of violent change. The New Madrid earthquakes of 1811 and 1812 were so powerful they were said to have caused the Mississippi to flow backward for several hours, creating Reelfoot Lake in Tennessee, where there had been only forest floor. The river has a memory of cataclysms. But the crisis it faces now is not one of sudden violence. It is one of slow, creeping attrition. For most of modern history, saltwater intrusion was a rare event. The 1988 incident was the benchmark, a crisis that reached the west bank of Jefferson Parish and stayed for nearly 3 months, prompting the creation of the emergency protocols the Corps uses today. That was seen as a generational event. Then something changed. Low water events that triggered emergency responses happened in 2022. They happened again in 2023, when water levels at the USGS gauge in Memphis, Tennessee, hit minus 10.8, 1 feet, the lowest since records began in 1954. The interval is collapsing. What used to be a once-in-a-generation problem is now a recurring, seasonal threat. We have covered the history, the scale, and how we got here. The science is fascinating, but the consequences are what matter. If you find this kind of deep dive interesting, you can subscribe for more videos like this. Anyway, now we look at the cost. Now, here is the part nobody is putting on the news. The cost is not measured in just chloride levels, but in billions of dollars. That figure, a $20 billion loss in trade just from the 2022 drought, is an estimate so large it becomes abstract. So let's make it concrete. Let's talk about a single barge. A standard tow on the Mississippi can push 15 barges, a configuration that stretches a quarter-mile long and carries the equivalent of over 1,000 semi-trucks worth of grain, coal, or chemicals. To float that weight, it needs water. When the river level drops, the authorized 9-foot deep channel becomes 8 feet deep, or 7. For every single inch of draft a barge loses, it must offload cargo. The math is brutal. For a standard 15 barge tow, a 1-inch drop in river depth means a loss of about 25 tons of cargo capacity. When the river drops by a foot, that is 300 tons of corn or soybeans that must be left on the dock. When it drops by 2 or 3 feet, the entire economic model of river transport begins to fail. This is the reality for farmers like Tom Jennings in Missouri. A farmer's year is a gamble on weather, markets, and machinery, but they have always counted on the river. The river is the final step, the gateway to the global market. 92% of the nation's agricultural exports leave the country via the Mississippi River system. Farmers harvest their corn and soybeans, truck it to a local grain elevator on the riverbank, and sell it. From there, it is loaded onto barges and begins its long journey south to the export terminals in the Gulf. But in 2022 and 2023, the elevators started turning trucks away. Not because they didn't have orders, but because they had nowhere to put the grain. The barges weren't coming, or the ones that were could only take on a fraction of their normal load. Freight rates for shipping what little they could move skyrocketed. Farmers were left with an impossible choice: let the harvest rot in the fields, try to store it in already full silos, and hope the river rises, or sell it on the spot for catastrophically low prices. Paul Rhoda, an official with the Waterways Council, puts it in stark terms. He says, "It comes down to who is going to feed the world. American farmers can provide that, but we need to make sure we have the transportation available. The bottleneck is not on the farms, it is on the water. It is a traffic jam caused by a lack of pavement. And the ones trying to repave it, second by second, are the dredgers." Lou Del Orco is the Chief of Operations at the St. Louis District of the Army Corps. His job is to keep the channel open. His primary tool is the dredge, a vessel that is essentially a giant underwater vacuum cleaner, sucking up sand and sediment from one part of the riverbed and moving it to another. It is a constant, unending battle against the river's natural tendency to silt in. In a normal year, his district might move 3 to 4 million cubic yards of sediment. In 2022, they moved 10 million. Crews worked 24 hours a day, 7 days a week, chasing hot spots where shoals were forming and threatening to close the channel entirely. At one point, over 1,000 barges were stuck in a queue near Memphis, waiting for the channel to be cleared. The economic cost of that single backup rippled through the supply chain for weeks. It's a ripple effect that most people never see. Low-key, send this to a friend who might not know this is happening. The work is heroic. It is also, some argue, a sign that the system itself is becoming unsustainable. And the cost is not just economic, it is infrastructural. Back in Louisiana, the threat is not just that the water tastes bad. When the chloride concentration in the water climbs, it becomes corrosive. It attacks metal. The vast unseen network of pipes that deliver water to homes and businesses is a mix of materials: iron, copper, and in many older systems, lead. Saltwater accelerates the corrosion of these pipes, potentially leaching heavy metals into the drinking water. Suddenly, a logistical crisis becomes a public health emergency. For the 18 million Americans who get their drinking water from the Mississippi and its tributaries, the health of the river is not an abstract environmental concern. It is a matter of personal safety. The water utility in New Orleans had to purchase millions of dollars worth of water from upriver and construct emergency pipelines to blend it into their system, diluting the salt to keep it below the EPA threshold. This is the new price of survival on a river that is fundamentally changing. The battle of the sill, the struggle of the farmers, the race of the dredgers. They are all symptoms. They are reactions to a problem that began hundreds of miles away and months earlier. A lack of snow in the Rockies, a dry spring in the Ohio Valley. A summer heat dome parked over the plains, evaporating moisture before it can ever reach the streams and creeks that feed the great river. We have built our modern world on the assumption of a stable river, a predictable river. For 100 years, our primary challenge was too much water, floods. So we built levees, taller, straightened channels, and created a system designed to move floodwater to the sea as fast as possible. Now, we face the opposite problem, not enough water. And the very system we built to solve the first problem is exacerbating the second. The straightened, channelized river has no time to linger, no wetlands to slowly seep into and recharge. It is a gutter, designed for efficiency, and when the rain stops, the gutter runs dry. This is the existential question buried in the data from the USGS stream gauges and the NWS river forecasts. If a river we have spent a century and billions of dollars to control is now behaving in ways we cannot predict, what does that say about our control? Dr. Torbjorn Turnquist, a geology professor at Tulane University, studies the very ground the river flows over. His work shows that the Mississippi Delta is subsiding, sinking, at the same time sea levels are rising. The low river flow and the saltwater wedge are not happening in a vacuum. They are happening at a moment when the land itself is getting lower and the ocean is getting higher. It is a three-front war, and the river is caught in the middle. The fight is no longer just about navigation or seasonal drought. It is about a fundamental shift in the relationship between the river, the land, and the sea. A shift for which our current infrastructure was never designed. What happens next? The Army Corps has become more efficient at their emergency responses. They know how to build a sill faster now. They have pre-positioned dredging equipment based on the lessons of the last few years. But these are responses. They are not solutions. No amount of dredging can make it rain in Iowa. No underwater sill in Louisiana can make up for a lack of snowpack in Minnesota. The system is too large, too interconnected. The solutions, if they exist, must be just as large. They involve conversations about water conservation, about agricultural practices, about the very future of shipping on a waterway that is becoming less reliable every year. 3 questions hang over the entire Mississippi Basin tonight. How long can we rely on last-minute, multi-million-dollar emergency measures to hold back a crisis that is becoming chronic? Why is the system we built to tame the river now making it more vulnerable to these new threats? And what does it mean for the economy, for the food supply, and for the 18 million people who drink its water when the nation's most powerful artery begins to fail? The water that should be flowing past Memphis right now is still locked in the ground in North Dakota, or has evaporated under the Texas sun. The river is a reflection of the continent, and the continent is getting drier. Somewhere on the riverbed near Baton Rouge, in the dark, the line between fresh and salt is being drawn and redrawn with every tide. The pressure from the Gulf is constant. The pressure from upstream is not. And tonight, hundreds of barge captains are checking the river gauges, calculating their loads, knowing that every inch of water beneath their hull is the difference between profit and loss, between a successful delivery and another week spent stuck in the mud, waiting for the river to rise, a river that may not have the water to give. The scientists at the National Weather Service's prediction centers run their models. They look at soil moisture, at long-range forecasts, at the lingering La Niña or the coming El Niño, trying to give the people on the river a few weeks of warning. But the warnings are becoming bulletins for a slow-motion disaster. It's a system so vast, its inertia is measured in seasons, not days. The decisions we have made over the last century, the concrete we have poured, the channels we have dug, they have all led to this moment. A moment where the mightiest river in North America is locked in a silent, losing battle with the ocean at one end and a drought at the other. And somewhere below New Orleans, the saltwater wedge is still testing the sill, waiting for the flow to weaken, waiting for its next chance to move inland.